Hello, I'm Stuart Winter, the platform architect and developer for Slackware on the ARM platform. Now, in this video, I'm going to talk to you about what's happened to the power supply for one of my Banana Pi test machines that's used to test the Banana Pi support in Slackware ARM 32-bit. In the previous episode, you saw me assembling the build machine, which is going to be the stable builder for the Slackware ARM 32-bit 15.0 release. And you also saw me testing U-boot on there. So U-boot worked perfectly fine on that machine. Subsequent to that video, of course, I went to test it on the Banana Pi, and I installed the latest version of U-boot onto the SD card on this Banana Pi. I rebooted it remotely and watched U-boot boot. I attempted to boot the Slackware installer, and it loaded the kernel over TFTP. But when it came to loading the Slackware installer, it kept timing out downloading it. It's pretty big, the image. You see these T symbols as it downloads over the network, which means it's timed out. So I thought there must be a networking problem. So I checked the cable, it was fine. And I was a little bit concerned. And I suddenly thought, I just wonder if it's the power supply, because I've had power supply issues before and they cause the machines to behave in peculiar ways. So I've retrieved the machine from the build server room and I've brought it here. So I'm going to show you what happens when I try to boot this machine. Alright, so this is the Banana Pi. It's an all-winner A20 dual-core 1 GHz CPU. It's got an SD card, it's got USB OTG, it's got power button reset, it's got video output. Which one is that one? I've forgotten what you use that for off the top of my head. But it's got audio jack, of course it's got USB, it's got UART, so we can use the serial console. It has HDMI, it's got Ethernet, it's got USB 2.0 and eSATA, and it's got a power for the eSATA as well. This machine originally was called the Banana Pi, but now it's called the BPI-M1. So this is one of the original ones. This is pretty old at this point. Okay, so that's the Banana Pi, and it's powered by this power supply. So this is the original power supply that I bought with it, and this one must be now about 6 years old. So this machine's been running for about 6 years off of this power supply. So I'm just going to plug it in. It's a micro USB connector there. So I'm just going to plug it in a moment and plug it into the power. This machine is connected to the x86 laptop here over the UART. So I'm accessing the serial console of it over the UART. And I've got that connected here. So on this screen, we'll watch what happens when it boots. So I've got, I'm using the screen software to access the serial port. So we'll see what it does when we boot it. So I'm just going to plug that into the power and we should see it booting up. Okay, right, so the power's on. Okay. Oh yes, I've also got it connected to the HDMI. So on this monitor here, this is connected to the HDMI port of the Banana Pi. Okay, so as you can see here, it's simply hung on the first stage bootloader. It's just nothing else is happening. And this is the HDMI monitor that's connected to it, and there's absolutely nothing on there whatsoever. In a nutshell, the way that the boot process works is that there's 3 boot stages. The first is that there is a bit of software called the primary program loader, and that resides in ROM. The job of that is to load what's called the secondary program loader, which is also called the first stage bootloader. It's the same, just different terminology for the same thing. And the job of that is to load the second stage bootloader. What we're seeing on the screen is the secondary program loader, the SPL, or the first stage bootloader. So this machine is basically booted into stage 2, and it's hung. So it's not loading the second stage bootloader. In Slackware ARM 32-bit, at least on the Banana Pi, the bootloader, both stages 2 and 3, they're combined into a single U-boot binary, which is installed basically as a header on the SD card. So again, it's just got hung at stage 2. I honestly don't know why it does that. I don't. As I said before, when I rebooted it remotely, I was able to access the second stage bootloader into the console. I was able to load the kernel into RAM and get part of the installer loaded into RAM, but it presented network problems. I don't know why, but now it won't boot. So, as I said, I've been through this kind of thing before, and so there it is. And so I have this. Now, because it's the Banana Pi is powered via a micro USB cable, it's pretty easy to rustle up an additional power supply here. What I'm going to do is, let's first of all disconnect this. Okay, so just to show you. So this power supply outputs 5.25 volts and 2 amps, which is sufficient to power the board and this SSD. Fortunately, in the office here, all of my wall sockets also have USB power outlets on. So of course we've got, the power is okay, the voltage wise, and they're rated at 3 amps, which is perfect. So what I'm going to do here is just plug it in and show you what happens. Okay, right, so if you come and have a look this time, and we'll see what happens when we plug in a different power supply. Right, let's plug it in. Oh look, it boots. And then look, if we have a look on the HDMI monitor, you'll see it's also, the HDMI monitor is lit up now, and we should boot Slackware. Yeah, there we go. The Initard D is loaded. I think this is a fully configured OS. It should have been. It was one of the build machines. And there we go. There we go. Yeah, it's booted. So, I haven't got any peripherals connected to this, so I'm just going to, I can log into here. So I'll log in over the serial console and shut it down. Okay, so we proved that simply replacing the power supply has allowed the board to function normally again. So what we're going to do now this cable is required for booting in another Banana Pi that I have. So I need to make a new cable. All right, so I don't believe in wasting things. So what we're going to do, this power supply is broken. So what I'm going to do with it is I'm going to join these two. So what I tend to do is, this is a charging cable for an Apple device, an iPhone or iPad or something. And this has been in the car to charge the phones as we're driving. So I think it's, from memory, I think it's this end that's damaged, whereas the USB end is okay. So what I'm going to do is cut the end off this, because it's useless now. And I'm going to strip it down. So I can just expose the positive and negative electrical wires. We don't need any of the data, of course, because we're only using power here. So I'm just going to strip this down. Now you have to be pretty careful with this. And by the way, I'm not suggesting anyone actually does this at home. I do know what I'm doing, so...
¿Es seguro?
Yeah, definitely. It's very safe, yeah. I know what I'm doing, but yeah, I wouldn't recommend doing this at home. If you've got any ideas, perhaps consult a website where it's explained in detail about what you should be doing, but I'm just going to strip these wires down. This is the only thing about stripping really thin wires. Okay, so I've stripped those down a little bit. And then I'm going to strip this one as well. So I'm just going to save a little bit off the end there, because I want to have a look at that later. I want to measure the voltage out of that to try and get an idea of what's happened to it. Although I don't think I have the sufficient tools to really do anything useful with it. I'm just curious. Right, so I'm just going to strip this one as well. Okay. I'm also going to strip this. This is the broken power supply, and you might wonder why I've attached terminal block to the end of it. The reason is because I want to verify which is positive and negative on these wires. Now it should be red is positive and black is negative, which means I should be able to simply wire these two together, positive to black, red to red. But I'm not entirely sure. I wouldn't always believe the colours of cables. I simply want to verify that it's correct before I wire them together. So what I'm going to do is plug that in. Again, I wouldn't actually suggest doing this at home, but I'm just, if you know what you're doing, you can. I do know what I'm doing. So what we're going to do, I've got a voltmeter here, so I will set it onto 20 volts.
No vas a quemar la casa, ¿no?
No, of course not. The reason why I've connected a terminal block on the end is simply that it's a lot safer and easier to test this stuff rather than having bare wires, because what tends to happen is the wires end up touching themselves and you'll short it out and then you will have an electrical fault. So what I'm going to do is I'm just connecting up the black to black and red to red, and we're going to measure the voltage of this and check the polarity. So you can see on the meter that it's 5.83 volts, which is actually, I think, quite a bit higher than it says on the power supply itself. If I reverse them, you'll see, look again at the meter, you'll see if I connect red to black and black to red on the voltmeter, you'll see that it's now negative. So it means that the red really is positive and the black really is negative. Okay, so that said 5.83 volts, and the output's supposed to be 5.25 according to the text on the adapter there. I don't have any more equipment to verify anything else there. Okay, so that's done. We're going to do the same with this as well, just to simply verify it. Now, the only thing about this is that when...
Why are you verifying?
I'm verifying the polarity. So because otherwise, if I connect negative to positive and positive to negative, then that's going to cause a problem. It might actually, that probably will trip the power in the house and all the lights will go out. So we don't want to do that. That could cause an electrical fire or something like that. So I always verify anything like this before I start wiring things together. So the only thing about this is that it makes it quite difficult on a small, because the strands of wire are so thin, it actually makes it quite tricky to get a solid connection when I screw it in. Where's the solder gone? I thought I bought... Oh, it's on the floor. Right, so I'm just going to quickly just add a bit of solder, because I'm going to solder this stuff together afterwards. I don't use terminal blocks, I just solder it. Putting a bit of solder on here just means it's a lot easier to clamp down the screw in the terminal block so I can test it. And then once I've tested it, I can simply just solder the one onto it with the solder that's on the board. Usually when you do this, you put the cable in like a little clamp, but I don't have one here. So let's just put a bit of, try not to inhale the solder fumes. Okay, so I do the same thing again. I prefer working with thicker cables. It's a lot easier. In some respects anyway. That's kind of secure enough. Right, let's run the same test again. Plug it into here. Make sure they're definitely not touching. No. Okay. All right. First of all, do the inverse. So I'll connect the red to the black and the black to the red. All right, so yeah, so you see negative just about 5 volts, if I actually can hold it still. Yeah, so it's negative 5 volts. So we know that and I'll do it the other way around. And of course, now we've got positive 5 volts. And as you can see from the wall socket, it's not 5.8 volts, it's 5 volts, almost on the dot. So it makes me wonder whether the voltage is too high for the board, and that's what's causing the problem. All right, so now what we're going to do is I'm going to solder the two together. Now I verified that the colour scheme is consistent across the two bits of cable. Now I must say, ever since I was a kid, this is my level of soldering has not actually progressed beyond wrapping the cables around and then folding them back over each other. But of course it works, so and it's safe enough. Es muy seguro.
Es muy seguro.
Sí.
Si tú lo dices.
Siempre. Right. Okay, and then so the colours are definitely correct. Yeah. So let's solder those on.
They better be.
Well, don't worry. The electricity is sufficiently protected, so it's got an RCD on there. It'll trip out if it's going to cause a problem. Okay. Yeah, it's not pretty. Don't use me as an exemplar of soldering, because that's not me. Okay, cool. So I just need to find the PVC tape from the desk. Let's tape that up. It's a little bit messy, I have to say.
That's why I do the Christmas wrapping.
Thanks. That is indeed why you do the Christmas wrapping, yeah. No es precioso, es muy práctico. See? Vale. Okay, so this is the moment of truth. Does it actually work? Of course it does. Right, so...
It always works.
Of course everything always works. Not necessarily immediately, but it always works, and we should see it booting on the screen. There we go, the machine's booting with the new power supply. So there we go, that is done. So we've got the old power supply. It was running at 5.85 volts, I think. Probably that's what's wrong with it, but it certainly isn't 5 volts as it should be. I now have a functioning banana Pi that I can return to the build rack with all the others. And what I'll also be installing in the build rack is the same electrical sockets as I have on the wall here, albeit smaller versions of them. And start using, oh, this one's different actually. This only outputs 2.1 amps. The others are 3. I didn't notice that when I bought it. But anyway, don't do this kind of thing unless unless you know what you're doing with electrics, of course. But as you can see, it really is quite easy just to, when the power supply breaks, simply plug it into a new one or power it from USB. And this does happen over years of running these power supplies. They just degrade over time and start to fail. So there we go, the machine's booted again and the banana Pi is back in action. Thanks for watching. See you later.